In this particular session, we're going to talk about DP with bitmasking. So, firstly, I'll talk about that what bits are, how computer represents the data in terms of bits, and then how we can exploit that to reduce the time complexity and the space complexity of our programs. So, let's get started with what are bits in general. Okay, so yeah. So, what are bits? So, let's say this is your computer, right? You try to store data into it. Now computer doesn't understand how to store the data, so it actually stores the data in terms of zeros and ones, and these are called bits, right? Now even if you're writing a program, so let's say you're using C++ and over there you declare a int or you declare a char or a float or a double whatsoever, so that actually is stored in terms of bits. Now let's talk about int in particularly. Now int basically means integer, right? Which can have values from -2 billion to +2 billion, right? Now integer is represented in 32 bits. Now what are bits? I already told you that they are zeros and ones. So technically each of them can have a value 0 and 1. So these are 32 columns, let's say. And each can have a value 0 and 1, 0 and 1, so on, right? So this is what bits are. And we can actually use this to speed up our programs. Let me try to give you an example. Now let's say you are working on a program where you have to save the states. By that I mean, let's say you have to save that have you visited the index I or not, right? Now you can say that okay, I can do it with the help of a boolean vector, or yeah, vector of bool, or array, boolean array, or you can say yeah, bool array. Now let's say I say that the index I is having value up to 20 maybe. So I can go up to 20, or there's just 20 elements in the entire array, right? So you'll say, okay, fine enough, I'll declare an array of 20 elements, or let's call it visited array, or any sort of that name that you prefer. Now for each of these indices, when you have visited them, so you will mark that as visited or you'll set them as 1, right? But there's a better thing I can do. So I already know that int actually is a collection of 32 bits. So since int is a collection of 32 bits, I can utilize this. So I'll say that, okay, I'm not concerned about the other bits. I'm just concerned about the first n bits. So over here, let's say my n was 20, or I was just having 20 elements. So as we know, each of them, so this is the representation of int, right? Each of them can have a value 0 and 1. So I can say if a bit is set to 1, that means the particular index has been visited. If it's not set to 1, then that element has not been visited. So that's the entire idea about bits. Now I want to talk about the left shift operation and the right shift operation. So there are operations that you can perform on the numbers, right? So like you in decimal numbers, you can like add two numbers, multiply two numbers, divide two numbers. So there are popular operations in terms of bits as well. That will take another couple of minutes, but up till this point, is everyone on the same boat? Everyone is able to understand what I'm saying? Or any doubts? Guys, are there any doubts? Okay, cool. Okay, so what are the operations that you can do in bits? So you can have a AND operation or operation, right? Or a left shift or a right shift operation. So what are these? AND operation basically means that when you AND two numbers, right? Now let's say this was your int 1, or let's say this was int A, this was int B. Now there would be several bits that would be set in it, and there would be several bits that would be set in it. Let's say this was like this something. Okay, so wherever both the bits would be set as 0, it would remain as 0. Or wherever, even if one of the numbers is set as 1 but the other is set as 0, even that would be 0. So answer of A and B would be, this would become 0, this would become 1 because both the bits are set over here. This would become a 0, this would become a 0, this would become a 0, this would become a 1, this would become a 0, and this would become a 0. So this is basically AND operation. I'm just trying to speed it up so that I don't waste a lot of time, but I also wanted to give you a basic introduction. And what about the OR operation? So there's another operation known as OR. What it does is that it ORs up the values. By that what I mean is that even if one of the bit is set, it would become set in both in the final answer. So for this, let me just change the color. Yeah, for this both the bit for 0, so its value would be 0. For over here there was one bit that was set to 1. Over here there was one bit that was both the bits were set to 1, so the answer is 1. For this the answer would be 0. For this would be 0. This would be 1, right? This would be 1, this would be 1, this would be 0. Cool. Now there's another thing that we need to understand, that's the XOR operation. So in XOR operation, the final answer is 1 only if one of the bit is set and the other bit is not set. So over here, both the bits are not set, so the answer is 0. Over here, only one bit is set, so the answer is 1, right? Over here, both the bits is set, so answer is 0. No bits are set, answer is 0. No bits are set, answer is 0. One of the bit is set, so the answer is 1. Okay, both bits are set, answer is 0. One of the bits is set, so answer is 1, and this is 0. Cool. So these are the basic operations that you can perform. Now what about left shift and right shift? So left shift basically means that if you are having a number, so let's say I have the value 4 with me. So value 4 can be represented like this in binary format. I hope everyone is clear about that. This is the value 1, this is 2, this is 4. So you're saying only the second bit is set. This is 0th bit, first bit, second bit. So only the second bit is set. So 2 to the power 2 is what you're getting, right? Now if I say left shift by 0, right? So this is the like the symbol you use for left shift. So what would happen is you can clearly see where it's pointing at. So it's pointing at the left location. So your variable would get left shifted. By what amount? So let's say it's mentioned that 2 units over here. So they'll get left shifted. So initially you were having this. Now they'll become 1 would come over here, 0 would come over here, 0 would come over here, right? Let's say it was like this. Now the remaining things would be filled up with zeros. So your value would become now 16, right? Now what about right shifting it? So right shifting is represented by this formula. When we do this, so your, let's say you right shifted 4. So your 0 by let's say 1 unit only. So your 0 would come over here. This would, okay, so this is come over here. This would come over here. Yeah, 1 would come over here. If this is the representation, right? So this actually went out of bounds. This particular thing went out of bound. So we'll cancel this. So we'll cancel this out, and the value you'll be left with is 2. So left shifting and right shifting basically means multiplying a certain number by 2 itself. So if we are right shifting a certain number by, let's say, x units, that is similar as dividing it by 2 to the power x. So if I'm right shifting a number n by x units, so it's similar to n divided by 2 to the power x. If I'm left shifting it by x units, that's similar to multiplying it by 2 to the power x. So yeah, that was the thing I wanted to discuss with you first before I move ahead. Now is everything clear up till this point? Is the pace fine? You want me to speed it up or bring down a notch? Cool. Okay. Cool. So what's bit masking is clear. Now we can use this particular thing. As I told you that we can use this particular thing to mark that whether a particular index was visited or not. And that is definitely the biggest use case of, I'll say, bit masking, because whenever you'll see a question wherein the number of indices or the number of states you're going to is going to be less than, let's say, 32, right? So we'll get to know that, okay, 32 can easily be represented, or 32 states or 32 zeros and ones can be easily represented by using an int as a mask. So you'll be using bit masking over there. Now why bit masking? So the biggest advantage is that it allows you to reduce your space. Now let's say if I had a question wherein I had to save like 30 states. So 30 states is what I wanted to save, right? Now, if you're not comfortable with states, I would recommend you to, firstly go and watch the video that I had published earlier, or that the session which I had earlier on DP. So over there, we talked explicitly about states, what our states are. So let's say I wanted to visit 30 states and I stored it in a vector of bool, right? So this would take me 30 into 1 bytes, or how much bytes does a bool take? It should be 2 bits actually. So this is going to be a big number, right? Or if I store it in int, right? So let's say even if the values are zeros and ones, I'm still storing it in int. This is going to take me 8 bit for each of the variable, right? In total, I'm going to have 30 variables. So it's going to take me 240 bits. This isn't even the biggest issue. The biggest issue comes when you want to save it. Now it's pretty easy for me to save integer, right? I can have a DP array. I can have anything. I can easily store a DP inside it, or I can easily store an integer inside it. What if I ask you to store another vector inside of a vector? That starts becoming tricky. and that would lead to unnecessary computation which you could have avoided. So that's where this kicks in. Now this would become more clear as I discuss a particular example with you. So this is the particular example I wanted to discuss. Now this is a problem, little elephants in alcohol from Codechef. The only thing is that since it's Codechef, the constraints are pretty linear, or it's pretty lenient, I'll say. So even an unoptimal solution would actually work over here, even if you're not using DP and all that stuff. It still would work over here. But this sounded like a cool example which I could show you. Reason being, bit masking mostly is used in case of scenarios where the question is pretty tough, right? So had I discussed some question from Codechef or some question from Code Forces or some other platform, the question itself would have been so tough that the motivation of teaching DP with bit masking would have been left behind. So this is the question I've selected. So let's go through the question. At any moment, if you feel that I'm going a bit fast, you can let me know. If you have any doubts, you can still interrupt me. Cool. So the problem states that the little elephant and his friends from the zoo of Lviv were returning from the party, but suddenly they were stopped by the policeman Big Hippo, who wanted to make an alcohol test for elephants. There were n elephants ordered from left to right in a row and numbered from 0 to n minus 1. Let Ri be the result of breath analyzer test for the ith elephant. Considering the current laws in the zoos, elephants would be arrested if there exist k consecutive elephants among them, for which at least m of these k elephants have the maximal test. Okay, so there's some gibberish. I'll just explain you what the question wants us to do. Cool. So what the question asks is that you are given an array. I'll stop that gibberish with the elephants and hippos. What I'll say is that this is an integer array that is given to us, and the question states that there are n indices or there are n numbers that are given to you. Now these could have any value. So let's just take the example that they have given. So the value they have given is 5, 3, 2. So let's say this was the array that was given to you. That was 1, 3, 1, 2, 1. Over here the n value is definitely 5 because there are 5 elements. The value of m is 3, and the value of k, it's nnk or nkm. Give me a second. Okay, so yeah, the value of k is 3 and the value of m that they have provided is 2. Now I'll explain what these values are, don't worry about that. So cool. So these were the things provided to us. That basically means that we have an array of 5 elements. This is an array of 5 elements. Now we want to check that in any window of 3 elements, right, the maximal element should not appear 2 or more times, right? So let's say we select this particular window right over here. Okay, give me a second. It's a lot of okay. Okay, cool. Yeah. Okay, so let's try to select some windows. So over here, let's say this is the window. What is the maximum element in this? The maximum element is 3, right? How many times the maximum element is happening or occurring? It's occurring just one time. 1 is less than m, which is set to 2, so it's fine. Let's check for the other next window. So yeah. Okay, so this is the next window right over here. Now what is the maximum element over here? So the maximum element is still 3. The number of times it's occurring is just 1. 1 is less than 2, so it's still fine. What is the next window? So the next window would be this one. Okay, yeah, this one, that is 1 to 1. What is the maximum element? The maximum element is actually 2, which is occurring again one time, which is less than 2, so that's also fine. So over here you don't need any operation. Now what is the operation? So the operation they're defining is that for in a single operation you can increase any element by 1, but the case is that you cannot increase a single element more than 1 times. By that what I mean is that if you have already increased the element I, right, if you set the element at I from ai to ai plus 1, right, you can't increase it again. And you have to tell them that what is the minimum number of operations you need to do to make this array valid, or to come up with a solution wherein the window does not have with a window of size k, or any window in the array of size k does not have the maximal element with a frequency more than m. Is the question clear, or is there any doubt in the question? Okay, anyone else? Okay, it's clear to all. Okay, let's then jump to the solution, or let me talk about the solution. So this can easily be done by recursion, right? So where's my cool? Okay, so I'll be discussing the recursive solution to it, and then we'll try to optimize it and come up with the bit masking approach and how do we use it. So firstly, I'll take the inputs, that is n, mm, n, k, and m. Then I'll take the entire array. After that, let me use a Boolean vector that would save the states. So Boolean vector would tell me whether I've added one number to the current index or not. Cool enough. Then I'll use a function that is recursive functions. I'm just calling it REC. You can change the name to whatever you want. It will take an index. So what is the current index? Then it will take the vector Boolean vector. Then it will take the actual vector that you were having. Then it'll take the three inputs that you had, that was n, m, and k. Then this is the base case. Let's not talk about the base case, or let's not talk about the terminating addition. But what it checks is that if for any element you will be having two choices. So the choices would be not to increase it. Okay, sorry, not to increase it, or the second choice would be to increase it by 1, right? So if we don't increase it, then I can say that the number of operations would be returned, and I'll have to go to the next element that would be represented by idx plus 1, right, or the index plus 1. The rest of the parameters are gonna remain the same. In other scenario, let's suppose that I increase it. I increase this, right? So if I increase this, I change the vector, or I change the representation to 1. Then I say that result is going to be the minimum of whatever I received earlier. Or I can say that since I increase it once, so the number of operations are 1 plus whatever answer I'll be getting for the rest of the array. So recursion of index plus 1, then all the remaining inputs. After you've got an answer over here, so you'll set the element back to 0, and then you'll return the result. Now let's check for the terminating condition. So the terminating condition is that for all the elements, so this is a standard boilerplate code, I'll say, or pretty easy code. So I'm just checking that in each of the windows of size k, is my maximum element increasing the value that is m. So is my maximum element present more than m times? If it's so, I'm returning 1 is 6. Now 1 is 6. This is a value. This is a false value, I'll say. So when I'll be doing my computation, I'll check it over here itself, that if my value is greater than or equal to 1 is 6, then the answer does not exist. So I can do that over here itself. So that's the invalid answer, or invalid answer. Else I'll return a value 0, because we have already traversed all the indices, and with whatever computations we did, right now we don't need any operations, and we have reached to the end. That makes sense. So this is a standard approach for doing a recursive solution for it. Any doubts over here? Okay, let me move ahead then. Okay, so what can be optimized over here? Now over here you are able to see that we have a vector bool, right? Or we have a function or a vector that contains whether you have incremented it by 1 or not. Now technically it has two values, that could be zeros and ones, right? Can we represent this by a single integers by using the bits of that integers? That actually depends how many values at max can be there in added, right? Or in this particular Boolean vector. Now let's check for the number of values that can be over here. Okay, so what's the constraint? So the constraint states that n is going to be less than equal to 17, and we know that a Boolean of integer actually is represented using 32 bits. So since 32 is greater than 17, we can say that we can actually represent it using a integer, right? Okay, so that's what I'm gonna do. So let's try to change it over here itself. So I'll say that I want a mask. Okay, before I do that, let me just try to show it, try to run it once, so that you know it works or not. Okay, so it shows it's passed. So this is the input, this was the expected output, this is the received output, so everything is working fine. Okay, so what I can say is that instead of using a Boolean vector, I just wanted to use a mask. Now what is a mask? A mask would simply be an int that would actually represent whether a particular state was visited or not. Now you'll see a lot of errors over here. So it'll say, it's saying that it wasn't expecting all of this stuff. Now when you were checking for the current value, you were saying it's value vi plus j, or the value at the particular index. and then you were checking whether that value has been incremented by 1 or not. Over here I'll say cool enough. So what I can say is that the value would be incremented by 1 if that particular bit is set. Now how do I check if that particular bit is set? So that can be checked by mask and that particular bit. So I'll AND it, because you know that in AND we'll get a non-zero answer only if both the bits are set, right? And what's the location of that bit? So it's I plus j, right? Now we'll check if this value is equal to 0, then the value is 0, else I'll have to add 1. Cool. After that, what I'll do is, okay, so we get out of here. Then over here we have to provide mask. That's fine. We don't need to do this now. Okay, so over here I can simply say mask, and I want to set this particular bit. Now which bit I want to set? The bit at the index idx. I can get rid of this. This looks fine to me. And initially the mask would be 0, right? I can get rid of that as well. Actually, I can get rid of this entire thing. I can make it even, more concise. So I'll say it's a minimum of this or 1 plus when I'm setting the mask. Let's try this out. Give me a second. Okay, recursive call, then use it for rec. This should be fine. Let's test it. Okay, it failed. Now I'll have to check why it's failing, but you got the gist, right? Like how it's working and why it's working. So let me check why it's failing. Okay, so if I'm setting the index I plus j, this should have worked. Index idx plus 1, or probably messed up somewhere. Let me give it a shot. If it doesn't work, I anyway have the required code, so I'll show you that. Just wanted to see why it's not working. Where did I mess up? Oh, got it. Yep, it passed now. So over here, what I did is that instead of using that Boolean vector, the vector that was telling me whether the particular index was incremented by 1 or not, now I'm using a single integer variable that is called mask. Now the code automatically becomes more concise because you're not using an unnecessary Boolean vector over here. And it's even easier for you to actually use a DP now. Now let's try to use a DP. But before using DP, any doubts? Guys, any doubts? Because I think we are moving at a good pace. So if there's any doubt, we can take it up. Cool enough. If there are no doubts, let me move ahead. So cool, I can actually use a DP over here. So what would be the states? My state firstly would be represented by mask, because mask would tell me that what all array. So if I'm standing at a particular index, okay, let me just explain that a bit. Okay, cool. So let's say this was my array, right? And these were the indices. Now I'm standing at this particular location I, right? Now it's possible that a few of the indices that are from 0 to I minus 1, I've already set them. Let's say I already increment this index and this index, right? Now standing at this particular location, its actual value or its state can actually be represented by 2 integers. So first integer is the index itself, that is I. And then I want to check what are indices are actually set, right? So the indices which are already set was initially being given by the Boolean vector, and it's now being given by the mask, right? So these are the only two things that I require. Now what would be the maximum value of a mask over here? Let's test that out, and it's an important concept to learn as well. So over here, you know that the number of bits that could have been set was 17, right? So I can say in the for the maximum value, only 17 bits would be set, right? So only 17 bits would be set. Now, how do I represent that 17 bits are set in a number which has 32 bits in total? Now, there are multiple ways of doing it, but one of the easiest ways to do it is that I can say that I'll shift my 1 18 times. When I'll do this, I'll get something of this sorts, 1 and all on and 17 zeros over here, right? And then I'll say I'll subtract 1 from this. As soon as I do that, it would become Okay, so when I subtract 1, so it's similar to when you subtract like 1 from 1000. So when you subtract 1 from 1000, right, what you get is a 999, right? So exact same thing happens over here, but it cannot be 9. It would be become a 1 because it's a binary number. So when you subtract 1 from this, it becomes all ones. So it would become all ones. So they are gonna be like 17 ones over here, followed by zeros, right? And this would represent that all the bits are set. But in total, how many states would be there? So like how many numbers could be here? So I already said the numbers that the minimum number is all bits set as zeros, right? The maximum number is all bits set as 1, or 17 bits set as 1. Now what is the number that can be contained in this, or what is the total number of states? So they are 2 to power 18, right? Which I can represent it as 1 shifted 18 times. So that's what I can do easily, right? So let me use a DP array for that. So I'll say that DP array can have one of the parameters could be that my current number can be shifted 18 times, right? And after that, the index itself. So what is the value of index? So the value of index can go from 1 to 17. So I'll just take a 18, just making it a bit bigger. I can say this can actually represent my DP state, represent my state, right? The first index is the mask, and the second index is the index. Yeah, pretty dramatic to say that, but anyway. So then I'll check that if my DP has a TP at mask and index, if it's not equal to -1. Now why -1? Because let's say in the starting of the problem itself, I set all the values of this particular array or this DP array to -1. So if any of these value is not -1 right now, so if the value at this particular state is not -1, that means it has already been computed. So I'll return that. So it would be DP of mask and index. Else I'll be doing all of this stuff. And before returning the answer, so even this isn't required now. Like, why do I want to store it in a result and then return it? So I can say return DP mask, okay, IDX, and I can say this. Okay, good. So this makes sense. Let's try to run it. Okay, it passes again. So the code is definitely working. But if you realize the amount of like if you really realize that what we have done over here, you'll be able to understand that you have drastically reduced the time complexity. Now, since it's Codechef and the constraints were pretty linear, you could have actually tried the brute force approach and you would have still got the AC if your like luck was with you. But this particular approach would definitely work because over here you're using a DP, you are using bit masking, and then you are reducing the time complexity. Moreover, now let's say CP is not your final goal, or you want to do great at CP, and other than that, you also want to get placed, right? Now, if such a question comes up in placements, interviewer would definitely expect you to come up with DP with bit masking approach for this, because even a noob can come up with a recursive approach, and a good company would expect you to do better, would expect you to reduce the time complexity as much as possible, right? So that's the benefit of learning bit masking, or that's the benefit of learning DP with bit masking. Because of it, you're actually able to reduce your time complexity and space complexity as well. Cool. If you want, I can try running it. I don't know if I messed something up, but let's just see about that. Are there any doubts, by the way? Guys, are there any doubts? Okay, I see a few thumbs up, but are you able to understand everything? Or Hawkrux, do you have a doubt? I'll not see the chat right now because I don't know what you texted, but is there any doubt? If there is some, you can let me know. Okay, so there are some chats. Nope, screen the you know. Okay. Okay, so you see your AC over here. That's well and good. Let's move to another question. Now this question is interesting because it utilizes maths as well as it utilizes DP. Now I'll be talking about this question. Now what this question states is that there's a bunch of gibberish, but anyway, so since it's small, I'll just read it out. So recently Watson learned the concept of coprime numbers and how he wonders, given an array a1 up to an, what is the size of the largest subset of the array such that each pair of the element in the subset is coprime. So that's what the question is stating. So what are co-prime numbers? So let's say you take any two numbers from this particular subset, that is A and B, and then you ask that whether they have a common divisor or not. So if they have a common divisor, they are not co-prime. So co-prime numbers are basically those which don't have a common divisor. For example, 3 and 5, maybe 3 and 7, then 7 and 5, 13 and 5, 13 and 7, right? These are actually prime numbers themselves. So if you want a different example, so I can say 8 and 9, right? So 8 is not a prime number, neither is 9. So but the factors of 8 are 2, so it's like 2 multiplied 3 times, and the factor of 9 are 3, so it's 3 multiplied 2 times. So they don't have any common divisors, and hence they are co-prime. So that's exactly what the question wants us to do. Okay, what is the largest subset of the array which such that each pair, okay, cool enough. So how can we do this? Now let's look at the constraints first. So it's actually divided into multiple things. So 25% of the test cases would contain number of these elements that would be less than 10, and the 75% test cases would contain number of elements that are greater than 50. Also, each element can go up to 50 itself. Now one could think that, okay, like bitmasking cannot be used because integers can only contain up to 32 bits, and over here we are talking about 50 bits in total. But you'll be wrong if you think that way, because up till 50, how many prime numbers are there? So let's just count it out. So the prime numbers up till 50 are 2, 3, 5, 7, 11, 13, 17, 19, up to so on. So there are basically 15 prime numbers in total. Now 15 is a small number, right? Or 16 is a small number, and you can easily store it in a integer itself, right? So we'll be using that. Now how will we would be doing it? So it's pretty simple. So firstly we'll be taking the input and then the array. Then we'll start our recursive function. Right? What the recursive function would do is that if you've already reached the end, right? If you've already reached the end, so let's make this out. If you've already reached the end, then you cannot add any more digit. So return 0. So basically the function returns the number of integers you can add at this from this particular index. So if you're standing at an index I, it will say that I'm not considered about what all indices you have already selected or how many indices you have already selected. I'll tell you that considering the indices you have already selected, how many more indices can you select, right? So if you have already reached the end, you cannot add any more indices. That's the base case. So return 0. If you have already calculated some answer, right, then you return that particular answer itself. Else, one of the possibility is that, okay, so you'll not consider the current index. So if you're not considering the current index, the mask would remain the same. So mask over here is basically stating that what all indices have already been considered, right? Or what all prime numbers are already set in the what all divisors are already set in the current subset, right? So if you are not considering it, the mask would remain unchanged, right? And you'll store that in a value, let's say q. Then you'll say that if the current element is 1, right? Now what would happen if you take 1? Anyone? Okay, I'm not gonna solve it. I'm gonna keep that as a homework question, so you can ask that on the group itself. So I'm not gonna tell what happens over here. But then you say, let's make a mask. Now what would be the mask itself? Now we know that there are 16 prime numbers in total, whatever. Yeah. So for those 15 prime numbers, I want to check that what all prime numbers are actually a divisor of this particular number, right? Now I'm gonna check that. And also, if let's say 3 is the divisor of this particular number, right? And okay, so 3 is the divisor of this particular number, and I've already selected another number that has a divisor 3. Then in that case, it's not possible for me to include this particular index, right? So in that case, I cannot do it, and I'll directly return my answer, because I'll say that, okay, I cannot be included, and or the index I cannot be included, and I've already calculated the answer in case I'm not including my index I over here itself, right? So if that's the case, I'll directly return it. Else I'll set my mask. So if the current index or the current number has a divisor x, so I'll set x in the mask itself. After doing all of these things, I can say that I want to try out that what would be my answer if I consider the current index. So that would be given by 1 plus because we are considering the current index. So that would be added to our subset. 1 plus whatever you'll get from the elements just after you. So we'll say 1 plus recursion of 1 plus 1 and mask. So mask you have already manipulated over here. So it's the updated mask now. Or the answer that we were getting earlier without considering the subset, that is q, that you populated over here. Now the entire code has not been written by me because I wanted a clean code, so I actually copied it from one of the submissions, or the editorial submission, I'll say. But I just wanted to explain you the idea behind it. So is there any sort of doubt? Let me try to submit it. And yeah, one thing I can state over here is that for this particular question, if I'm not gonna use DP, then I'm gonna get probably gonna get TLE. So this is one of those questions where you get a TLE if you're not using DP. So let me just do that for a while. Give me a second. Yeah, looks good. Yeah. So making these modifications, now I'm at a point then where I'm not using DP. Let's try it out if it works. Yeah. So this sample test case passes. Let's try to submit the code. Let's see if it passes as well or it fails because we are not using DP anymore. So it's a brute force approach. Okay, so it shows that it partially is accepted, and we are getting a TLE at one point. Now the reason we are getting a TLA is because we are not saving the DP states, so it's trying to compute every possibility, and when it will do that, so as you know that the time complexity would increase exponentially. Because of that, we are getting the TLA over here. So yeah, this is what the session was all about. There's one more question, but I'll share that in the Discord server. That's from Codechef, Code Forces. I don't expect everyone to do that because it's a hard question, but in case you are interested, you can try that even. Cool. So that's about it. So any doubts? Or anything you didn't understand? All good. Okay. If there are no doubts, I'm gonna close the session. For is there anyone who like studied DP with bitmasking for the first time? Okay, Abhi, that's cool enough. Yeah. Is there anyone?
Yeah, I'm studying for the first time.
क्या बोल रहे हो भाई?
मैं पहली बार पढ़ रहा हूँ.
भाई तेरे को समझ आ गया सब कुछ बढ़िया से?
थोड़ा थोड़ा आया.
कहाँ पे दिक्कत आ रही थी?
दिक्कत आ रही थी, थोड़े थोड़ी शायद स्पीड आपकी तेज थी.
क्या कह रहे हो? स्पीड तेज थी?
हाँ हाँ.
Okay, got it. So भाई एक request करूँगा that once this video is uploaded on YouTube, you can watch that. And other than that, in general also, whenever I'm teaching, so you're most welcome to ask me, to bring down the pace a bit. Yeah, you're getting my point, right? Because the only motivation is that you are able to understand. So if you're a beginner and still you're able to understand, that would be great. So whenever I'm teaching, so let me know if you're not able to understand something or the pace is too high or something like that. Make sense?
Yes, yes.
Okay, qubit. So for you also the pace was a bit high. Okay, qubit is typing. Okay, yeah. But you got the gist of it, or there's some part you want me to explain again? KG, what about you? Rotormax?
या आई मीन द कॉन्सेप्ट वाज क्लियर.
Mm-hmm.
एक बार खुद से करके देखना पड़ेगा.
Okay.
माइट नीड टू रीवॉच इट.
Okay, you need to rewatch it. Cool guys. So yeah, one advice I got from you all is that I need to speed it down a bit. So I'll try to do that from now. If there are any other recommendations, you can let me know on the Discord server itself, right? And I'll be posting a few more questions on DP with bitmasking. Try doing that as well. Okay, Ratan Kalpa is typing. Let's just wait for him. Then we'll close the session.
सर अगर आप टेस्ट केस लेके अगर कोड को क्लियर करेंगे तो और ज़्यादा अच्छे से समझ में आएगा.
Got it. Yeah, you're right. But the problem is that when I'm teaching DP with bitmasking, right? So if I'm taking a test case, like explaining the test case itself would be a big deal because in case of in the particular examples or the particular questions I did right, so there are 2 to the power n possibilities. Now even if there are like 5 elements, there would be 32 possibilities in total, right? So explaining all those possibilities is kind of tough. But yeah, I can try that from next session. Okay, Ratan, that's fine enough. So if you get any doubts from this, you can ask me. You can post on Discord, or we can take that up in the next doubt clearing session. That works, guys.
Yeah.
Okay, cool, guys. Thanks a lot. Bye bye.
Thank you. Bye.
Bye bye.